Welcome to The Explainer. Today, we're going to break down the fundamental fabrics that make us who we are, human tissues. I mean, really think about it. Beyond the obvious stuff like skin and bone and muscle, our bodies are actually built from just 4 fundamental types of material. So let's get into what they are and exactly what they do.
Here's our game plan. We're going to tackle this in 5 parts, looking at the core job of each tissue type from our outer defenses all the way to our inner command and control center.
All right, first things first. Before we can dive deep, we need to get a clear foundation. So what is a tissue, really? And what are these 4 fundamental types that build literally everything in our bodies?
In the simplest terms, a tissue is just a group of similar cells that all work together as one unit. Think of it like a super specialized team, where every single member is doing the exact same job, all focused on one shared mission.
And here's the part that just blows my mind. Despite how incredibly complex the human body is, every single structure, I'm talking from your brain all the way down to your big toe, is built from just these 4 basic types of tissue. That's it, 4. And here they are, our 4 master builders. You've got the protectors that form our shields, the connectors that give us our framework, the movers that generate all our force, and of course, the communicators that run the entire show. Okay, let's start with team number 1, the body's Department of Defense. This is our epithelials issue, and its main job is to cover and protect every single surface we have, both on the outside and on the inside. You can think of this tissue as a kind of living, intelligent wallpaper. Its cells are packed together super tightly, forming this continuous barrier. And yeah, it's designed to be tough, but what's truly amazing is how well it can repair itself. I mean, every time you've scraped your knee and watched it heal, you're literally seeing this incredible regenerative power in action. Now, what's really interesting here is how we classify this tissue. It's actually elegantly simple. It's all based on 2 things you see on this slide. First, how many layers of cells are there? If it's just 1 layer, we call it simple. If it's more than 1, it's stratified. And second, what's the shape of the cells? Are they flat or squamous? Are they cube-shaped or cuboidal? Or are they tall, columnar cells? And that's it. This simple grid helps us map out a surprisingly complex system. So, what does this all mean? Well, the crucial point is that the structure perfectly matches the job, right? In your lungs, for instance, you need a super thin, single layer of cells so gases can pass through easily. But on your skin, you need lots and lots of thick layers for protection from the outside world. It's a perfect case of form following function. Okay, next up, we've got the body's incredibly versatile infrastructure. This is the stuff that connects, supports, and basically binds everything else together. And you'll see it comes in some pretty surprising forms. So the secret to its versatility? It all comes down to a simple formula. Cells plus this stuff called the extracellular matrix. And it's that matrix that changes everything. For example, what if that matrix is a liquid? Well, you get blood. Yeah, we don't usually think of it this way, but blood is totally a connective tissue. You've got cells just floating in this liquid plasma matrix, constantly moving oxygen and nutrients all over the body. Okay, but what if that matrix isn't a liquid? What if it's more of a gel, something firm but still flexible? Then you get cartilage. That's the stuff that cushions your joints and gives your nose its shape. It provides structure, but with a little bit of give. And then, what if you take that matrix and you just load it up with hard calcified mineral salts? You get bone, the actual framework of your entire body. So this incredible range, from liquid blood to solid bone, all comes from the same basic recipe. And that is what makes connective tissue so absolutely essential. All right, let's move on to the powerhouses of the body. This is the tissue responsible for every single move you make, from blinking your eyes to running a marathon. This table here breaks it down perfectly. There are 3 distinct types. First, you've got skeletal muscle. That's the voluntary stuff, meaning you consciously control it to move your bones. Then you have smooth and cardiac muscle. Now these are involuntary. They work automatically, behind the scenes, doing things like digesting your food and, keeping your heart pumping, all without you ever having to think about it. And finally, we've come to the most complex tissue of them all, the body's sophisticated, high-speed information network. That's a pretty powerful statement, right? And it is completely justified. This tissue is the biological wiring that allows for every single thought, every sensation, and every action you'll ever take. And get this, it's formed by a network of over 100 billion nerve cells.
To put that in perspective, that is more stars than there are in our entire Milky Way galaxy. And each one of those cells connects to thousands of others, creating a system of just staggering complexity that regulates and controls everything your body does. So this huge network basically comes down to two main types of cells working together. You have the neurons. They're the rock stars of the show, generating and sending all the electrical messages. And then you have the glial cells. Think of them as the essential support crew. They provide nutrients, insulation, protection. They do all the background work so the neurons can do their thing. So there you have it. From the protective barrier of our skin to the complex thoughts firing in our brains, these four fundamental tissues work together in perfect harmony to create you. And understanding them isn't just basic anatomy. No way. This is the key that unlocks the future of medicine in fields like tissue engineering and regeneration. It really all starts with these basic building blocks.